KW Physics, I'm Mr. McConley. We're going to talk about resistance today. And when we say resistance, it's the resistance to electron flow. So if you can think of it like a water pipe in your house, we'll say, you can visualize that if you're trying to push a lot of water through a really small pipe, there's a limiting factor there. Eventually, it'll get to the point where you just can't get as much water through the pipe as you want to send if you're trying to send a lot of water through a pipe. And so you need to put a bigger pipe in. The same concept is true with electrical flow, which we call current. And so when you're trying to send a lot of current through the pipe, which is a wire or a conductor, you eventually reach a point where you can't send that much through anymore, and you got to use a higher quality or a larger conducting wire. If you think of it another way. It really helps to visualize this. If you had 5 people walking down the hallway outside here, it wouldn't seem crowded at all. You could walk fast, you could zigzag, you could do whatever you want, you could just get down the hall quick, because there's only 5 people. Now when we change classes, there's like a big rush, and we have all those people, I don't know how many there are, but say 100 people go down the hallway. Now you're limited by the fact that you can't go that fast because there's other people in your way, and you're bumping into them, and you're dodging them, and there's a slow person walking in front of you, and there's a person that has their bag, and so you can't go that fast because your flow has resistance. So that gives you kind of a conceptual notion of what resistance is. And in physics, there's an equation in the reference table. Resistance is equal to the potential in volts over the current, which we remember as in amps. So you would think the resistance might be volts per amp. And it could be, but there's anybody that's good at physics knows you don't say volts per amp, you say ohms. O-H-M-S, ohms. And it's given the Greek symbol omega. So when you talk about resistance, you're talking about ohms of resistance, and ohms is represented with the last letter of the Greek alphabet, the omega. Okay, you can see it on the side wall if you're trying to figure out how to draw it. So, ohms of resistance. So now, when you look at an electrical device, sometimes maybe you've already noticed this, you'll see a number with that symbol after it. And if you haven't seen that before, just check out your electronic devices, and you'll notice somewhere on there, there's usually that omega symbol, and they're talking about the resistance to the electron flow. Well, let's do an example with this equation here. For example, say I had 5 coulombs of charge, and they passed a certain given point in 20 seconds. And this was a flashlight, and this flashlight takes 2 AA batteries and has a potential of 3 volts. So I'm wondering, given this information, what sort of resistance is the actual filament, the light element, the light bulb? How much resistance is the light bulb providing, or how much resistance is the light bulb demonstrating if these are the numbers? So, 5 coulombs, that's a Q, that's a charge. This is the time, a T. This is a potential, a V, and we're looking for an R. So at first you're like, well, that doesn't even match my equation, because my equation is R is V over I, and I don't have I. And the reason I gave you this as an example is you got to do a little side problem, so it's a little bit harder than maybe your average problem. So we don't have I yet, but we remember that you can get I by
Charge over time.
right. I can be found by charge over time. So you can take your 5 coulombs, divide by your 20 seconds, and get your current. I'll let some people catch up. I see that you're copying pretty quick. Well, 5 over 20 is about a quarter, or is a quarter, so 0.25 amps, quarter of an amp. So now we bring it back over here, and we say, okay, you got 3 volts, you got a quarter of an amp, and when we divide those numbers out, Lucas says we're going to get 12 ohms. So this particular light bulb with this flashlight, or this flashlight setup, is providing a resistance of 12 ohms. Now, just as a little side conversation, different light bulbs provide different amounts of resistance. And when they provide different amounts of resistance, that usually indicates how much light they give off too. So do you think, thinking about it in your mind, do you think a light bulb that provides a lot of light is a little bit of resistance or a lot of resistance? A lot of resistance. Because if you're going to give off all that light, you got to be like resisting the electrons and using them to make the light, right? So I want you to keep that in mind, and our next lesson we'll talk more about that. Physics.